Okay, hello, hi, it's Ryan Ahmed with you, and in this video I want to explain to you a code that I wrote. The purpose of this code is writing a single function in Haskell that can do the following. If I do num2text of a normal number, it will transform it as such, okay, into normal English language written character by character, okay, literally. So let's first see what's inside this code, and let's first also test it. So let's say if I have num2text, okay, 1 2 3 4 5 6 7 8 9 10 0, you'll get it. Okay, now if I get something like zeros in between, say okay, it will skip the thousands. Okay, this is what will happen. Any thousands, and if I have like more digits, like billions, okay, it will skip them, okay, because there are zeros. Okay, and this I'm talking about the zeros because it's important because it's a special case in the way that I've programmed this code, and let's say I have it like this: 1 1 1 1 1 1 1 1. Okay, 11 billion, 100, and 11 billions, millions, and 100, and 11 thousands, and 111. Okay. Okay. So, and this is if you have more digits, let's say, okay, 100 billion, 11, and this is one more, 2. Okay, 1 billows. I made a new unit after the billions, let's say billows. Okay, just from the Minions. I just making fun. So the movie called the Minions. So 1 billion, and if you say like this, okay, if I added one more, it won't be correct because of the much that I've inserted here billows, okay, and billions and millions and thousands. So the system works here as if I say for each, like if I have 1 2 3 4 5 6 7 8 9 0, I would take each three, this three, I make a comma, like a virtual comma, okay, and I make each three like this and each three like that. Okay, so this comma is where later I will replace it with 1,000 and 1,000,000 and 1,000,000,000 according to the position. Okay, and whenever there are zeros, I also have to not write the 1,000 here, for example, or the million here, or the billion here. Okay, if it's a zero. Okay. Now, this is the list of units, okay, for each three. Okay, so this one is for the first three here. They don't take anything after it, so I just make an empty character. Okay, of course, I will have, I think you've guessed it, I'm using zip with in the bottom, okay, here, just to attach those words after the attaching them before the commas, if you want to say, but there won't be any comma already. Okay, this is just virtual, so I'm actually replacing every position of a comma here that you see with the suitable word, okay, from the 1,000 list. Okay, now this is the list of numbers. Okay, those are also some kind of special case. Those are the numbers between 20 and 100, okay, which are not ending with a zero, or you can say it another mathematical way, which don't divide by 10, okay, which are not divisible by 10, I mean. Okay, and here I made a translation, okay, from 0 to the word 0, and from 1 till 20. Okay, see all the teens too, and then those which are divisible by 10 between between 30 and 90. Okay, I write that words directly. Okay, and this between list here. Okay, if the number that is input here is it belongs to the between list, because it's between the 20 and the 30, the 40 and the 50, between the 40 and the 50, between the 60, 50 and 60, 60 and 70, 70 and 80, 90, and those are the between list. Okay, if that number is like something like 21 to 56, maybe 79, 77, something like that. Okay, all those, what I do with them is just I try to find the what do you call the tens digit here. Like for example, I made 2 and here the 1 from mod x 10. Okay, so this part will be translated into like something between 0 and 9. Okay, because you're taking any number here, and yeah, and then the number text here will by removing this one, I'll get the 20, and it will also be translated to any of the numbers here, this part. Now, if the number is greater or equal to 200 and less than, directly less than 1000, this is an integer I'm taking here. So I find how many hundreds are there. Okay, and I type like 2, and then type the number text by dividing by 100, because it's a number but over 100, so I get 101, 200 something like that. Okay, 500 something, maybe 900 something. Okay, so I get the number, the like, say here, like I have 956. So by dividing by using the div and dividing by 100, I'll get the 9. This is an integer division. I got the 9, and I got the 9, and by number text it will give me the word 9, and I add to it later the word 100, and because there's a continuation, and I do the rest for this one. Okay, so go number text. Okay, and this part will go in this part. Okay, or it will go to any of the rest here in this list. Okay, then here just to split it into 3 digits, like this, a list of 3 digits. So what I do is first 3 digits mod x 1000, so I get those 3 digits, and the other digits, those, okay, you will get them through dividing by 1000, integer division. So I'll get these. Okay, how many thousands are there, and using this function each 3 digits, I will make this list. Okay, this Haskell list. Okay, So now with using mapping and like by making this list, okay, I map it over this function, okay, which is the number text will translate each element here into its textual part, okay. So this is num2zip, okay. We will see num2zip how it will do it, but translate each three digits to text, okay. Will give you something like this. Like, let's say I have num2zip text, okay, 1 2 3 4 5 6 7 8 9 0, okay. So I'll get it like this. So this is the first part. This is 908 and 8, the 890 and 900, and then of course it has to be the reverse because I want to match with the order of the thousands list, okay. Then I will reverse it later, okay, reverse the whole thing later. So here, see, this is the part, okay, with the thousands later, okay, because it will do the num2zip will do a zip like this, okay. But this is just for testing, okay. This num2zip function is just for testing, just to show me how do they fit, okay. So if I, for example, let's say I had a 0 somewhere, like a 0 here, okay. Let's see, let's take the one all zeros. See, and 0 and 0. This is and 0. I don't need it. Okay, so anywhere where it says and 0 also, I don't want it. I want to skip this. Okay. Now, next thing to do is, of course, I must zip with, like, zip with each those, okay, by concatenating those two, or summing up those, or concatenating. Yeah, this will, like, each tuple will be like flattened as a one string, if you want to say. Okay, by concatenating them, okay. But when I do the concatenation, I want to skip everything everywhere it says and 0. So this here, it will be skipped, okay. And that's why I use this function fix, which takes the translation of the thousandths list element, okay, which is any element from the thousandths list here I mean, and then translation, okay. If the translation word contains the and 0, I will return it as an empty string, okay. The fix will be an empty string. And otherwise, just replace anywhere, because you will get any and 0 somewhere. You will get it, okay, for sure, okay. Because, for example, you say 100, you got 100 and 0. There's nothing 101 or 2, okay, because what you're doing somewhere here with the translation, okay. Here, when you do this, okay, if we go here somewhere, okay, sometimes, for example, here you got, what's this, like here, this is like the modulus will be 0, okay. Modulus here will be 0, so translate as a 0, okay. And I need to have the 0 written because it's a mark, just to get rid of it later, okay, in front of the, as we see here, okay. just to get rid of the millions and thousands which are zeros. Okay. And then and using the word and zero like this with the spacing, okay, will make it more unique. Okay, so it will be easier to filter it out. Okay, but we're not using any function called filter here. Okay, so so if I do this, okay, see, let's say I have num to zip with num zip with on x. Okay, like it will be this that part, just to redefine it. I'll reload it just to show you what this part means. Okay, so okay, so this is what will happen, and one, and so like this. Okay, and 1 billions. So that's why, and 1 billions at the end. And what will I do is I reverse it. Okay, so reversing this string will make it more credible in or more making more sense in English grammar. Okay, and then I concatenate it just to convert it as a normal string like that. Okay, and then I turn it back into as words. This way I get the spacing between each, just to get rid this and. Why do I have this and? So this is why. Okay, and then I drop one, which is the first one from this list. Okay, and then I do onward. Onwards, it's called onwards, sorry. So onwards, so this is how it goes back into normal sentence. Okay, into a normal sentence, and this way, this is what will happen over here. Okay, now the good thing about this, the replace is coming from the import data, so I had to import this function just to get going with it, or I mean just to get it done, or making it run. Anyway, so so here I'm replacing in the translation. This is the good thing. I'm not like, I did not just sum this first with translation and do a replace with any zero, or I did not even do like I tried before. This is faster because you try each time you call the replace on every translation. Okay, so you're like pointing directly where should the replace go. Although you are calling the replace function many times here, but if I do it maybe something like here, put a replace over here, okay, to go with the whole sentence, okay, and call replace once, it will take time to just to find all the words, okay, but this way I'm pointing where each like I'm just telling replace is there, okay, not anywhere else. Okay, So I hope that you enjoyed this explanation, and please subscribe to my channel, and like and tell your friends about it. Okay, thanks. Bye.